person Dr. Sanjeev Pradha, Director, Center for Mathematical Modeling, Chair Professor, Department of Mathematics, University of Colombo, Sri Lanka.
Good afternoon, respected dignitaries, distinguished guests, fellow professors, researchers, and dear participants. It's my great honor and privilege to warmly welcome you all to this international conference hosted by our institution. Today we are gathered here to share knowledge, exchange ideas, and strengthen global academic collaboration. We are especially honored to welcome our distinguished guest, Professor Sanjeev Pradha, Professor of Mathematics at the University of Colombo. Professor Pradha is a highly respected scholar with more than 25 years of experience in teaching and researching in applied mathematics and mathematical modeling. His research contributions span several important fields including interface physics, modeling, climate and environmental studies, and financial analytics. Through his work, he has successfully demonstrated mathematical science and addressed real-world challenges affecting society. Professor Pradha completed his PhD through the prestigious DAD science program in collaboration with the University of Kaiserslautern, Germany. Over the years, he has published numerous research papers in leading international journals and has made significant contribution to interdisciplinary research. He is also the co-founder and director of the Center for Mathematical Modeling at the University of Colombo, which has become an important hub for postgraduate research and international academic collaboration. In recognition of his outstanding contribution to research and evaluation, Professor Pradha has received several prestigious awards including the National Educator Award and multiple Challenges Award for Research Excellence. His dedication to teaching, research and mentoring has inspired many students and scholars both nationally and internationally. Today's conference provides with a valuable opportunity to engage in meaningful discussion, explore innovative research ideas, and strengthen collaboration among scholars from different parts of the world. On behalf of our institution, I extend my sincere gratitude to all our speakers, participants, and organizers who have contributed to make it the conference possible. Once again, I warmly welcome all of you and wish you productive and enriching conference. Thank you.
Thank you, ma'am. Next session, now I request Dr. Sanjeev Pradha, Director, Center for Mathematical Modeling, Chair Professor, Department of Mathematics, University of Colombo, Sri Lanka, to handle the technical session 3.
Okay, I think there is a technical issue, and without PowerPoint, I'll start my session. So let me actually talk about the now the talk is basically the, if you want to listen me, then you have to listen. Otherwise, you can go out, right? Yeah, so the talk is basically invasive plant, like how to identify the invasive plant, right? So this basically now if you look at the conference theme, it has environmental sustainability, right? So the environmental sustainability, of course, now this invasive plant play the major role, right? Now why this invasiveness is important? Right? Invasiveness is now kind of like example is not only this plant, not only the animal, like everybody of course having the invasiveness, right? Example, if someone of course try to talk here, so everybody of course follow. That's kind of like an invasiveness, right? So, for example, like we were worrying about like that now the tourists come because they of course interfere our culture, right? It's a kind of like an invasiveness, right? So your behavior also like that. I mean, a few minutes ago, it's an invasiveness, right? So this invasiveness is everywhere, right? But when it comes to the plant, right? Plant invasiveness is also the important point, right? Now, so why actually we talk about this is uncertainty, right? Now the behavior, kind of like the behavior is always uncertainty, right? The nice example is now, earlier you were talking, now you are of course is silent, like what does it mean like that? Now the geographical location and the environment and other kind of things affect the invasiveness. Now for example, if you select, if you find out that here the plant, maybe the dislocation plants considered as a normal plant, and wherever it's like this plant of course maybe in the other part of the India, in other part of the India, it's considered as an invasiveness. Now, the same thing for the tourists, of course. So when they are in their home countries, we don't actually consider like their behavior pattern as invasive, right? But when it comes to always like idea is like that. Invasiveness is depends on the climate condition, location, and all other kind of these things, right? Now you don't become the invasiveness, right? The people who come near, right? Excuse me, right? Don't become the invasive, right? Right? You look at like that now. Everybody of course follows the invasive, right? So the idea about the invasive is, so if the plant growth so much, right? So what has happened? That will of course harm to the agriculture product, right? So let's say example, if you think about the paddy and other things, now to grow the paddy is very difficult, right? But if you see like that, there are many insect plants, right? So those plants, of course, if you try to introduce like by mistake in the paddy, so it of course grow very fast, right? What has happened is that these plants they call the fertilizer. Sometimes of course the water also, right? So that will affect the paddy, right? Then you don't get the expected yield because of these invasive plants, right? That is the idea about the invasive, right? And I'm sorry I don't PowerPoint, but those I of course indicate about that normally in the world, I mean the entire world, like is basically the per year billion of dollars based due to this invasive plant, right? Because one thing is like that as expected yields we are not getting, that is the loss. And another point is like that now we use like a certain type of like that the chemicals to of course reduce the growth of the invasive plant, right? So that way now there are many type of like that the losses, right? And this losses of course count millions of dollars, right? And in India also the same. I believe like that, if I am not mistaken, it's something like that per year like 600 plus American dollars, US dollar million, right? So you see like that now this idea is important. But the question is how to identify this invasive, right? Now why this actually the invasiveness is important to identify the early, right? So now when of course people traveling from one place to another place, so we used to actually bring a certain type of like a plant because of the appearance. The plant of course appearing nicely. Of course, if it is of course having the nice flowers, so what has happened? People try to bring this, right? And then what has happened in the when of course now this new plant introduced to the new climate environment, what will happen? So those plants of course the enemies are not there, right? And they are of course if they of course getting that all the facilities like the fertilizer, sunlight, and all other things getting smoothly, right? So then this plant of course grow very quickly, right? So that will of course damage to the environment or the natural environment in that area, right? So I'm telling about like that there are many factors. One factor is now you can see like that certain plant of course having so much of seed, right? Now let's say example, now these are not invasive. For example, if you see the mango like one fruit item, one seed, right? But wherever it's like that they could take the other type of like this papaya, so you can see the mini seed, right? But obviously this papaya is not the invasive plant, but one of the factor is like that some plant of course generate mini seed, right? That is the one thing. And the second one is like that now the many flowers, right? So plant of course the many flowers, right? Early flowers, right? Million of flowers, and the million of flowers of course generate again the seed, right? And then there are plants like that whatever the part which of course generate the new plant, right? For example, like the seed, though even the branches, even any kind of things, even the root also generate the new plant, right? So that's the idea. I mean, those are the factors, right? And not only like that, now some plant of course the appearance, right? Now we like the different color, nice colors, and also like that. Now if the flower is very nice, maybe the branches are nice, so we try to actually the people take them, then keep it in their own garden, right? That is the appearance in the another factors, right? Look at these factors. There are many. There are 30 plus factors in order to find out the invasiveness. Right? The thing is like that the working with these many factors very difficult, right? And very difficult, and also like that the uncertainty is also there. As I mentioned that now the papaya, so it generates the many seed, but it cannot be considered as an invasive plant, right? So the same factor, same parameter, that's why we say the uncertainty, right? One parameter, number of seeds, higher the number of seeds of course now favor to the invasiveness. But wherever certain plant, of course like a papaya, it of course generates the many seed, but it's not considered as for the invasiveness, right? That is the uncertainty, right? Ecological uncertainty. Factors are there, but if you see that the factors, certain factors of course considered as the invasiveness, but wherever same factor was generate the highly accuracy, but however those plants of course not considered as invasive. That is called uncertainty, right? Same thing, but usually what has happened, if it is like because the but wherever the place we call this as a here, right? And the problem is like that now these parameters, we consider that these parameters as invasive support parameters, but of course now there are plant, even though now these parameters exist, cannot be considered as a that is the uncertainty. That is of course we call as ecological uncertainty, right? So the question is like that when you try to find out this early detection of the plant or invasive plant, that means you need to construct the index, right? Now you aware about the index. So the very simple index is like that. Now you do the exam, right? And then you are getting the mark, right? The mark out of 100, right? 80%, 70%, 50%. Those are index, right? Based on the index, the people can be, performance can be clustered, right? So variables like, I don't know the grading system, but for example, more than 80, you get the A, right? And the less than 80 and the 70, you get another grade, right? So that is the performance, right? So that's a simple type of like that index, right? And average, for example, if you do several subjects, right? You do the several subjects, so probably like that, then now the, I don't know about the grading system, if you have taking the EPA, right? So the grade point average or kind of like these things, right? So that considered as index, right? That's basically the index. And then the normally like that, when you look at like that, the various kind of like financial situation, must complete with this index, right? So which of course incorporate with the lot of parameters, right? As I mentioned about that, now the not only people who are aware about that, this share market, there are index, right? The index basically look at about the performance, right? What we want to actually like develop the index, but which of course provide the invasiveness, right? There should be a kind of like what you call the threshold. Beyond that threshold, you can consider as an invasiveness. And also like that, beyond a certain level, you can consider about that the very higher level, right? Or significant level of the invasiveness, right? I think now this idea is actually now, for example, when you look at like the income base, there are lines called poverty line, right? So that is the threshold. So the people, of course, you look at about that, now their income level, basically then we identify that the poverty line, right? So the poverty line is a kind of like a threshold, right? Here, our objective is like that they develop the index, right? Based on these 30 plus many parameters, like the parameters, and also like that they develop the, identify the threshold. From the threshold, so we could of course find out that whether this plant is invasive or not, and also even the invasiveness, of course you can rank whether it is a highly invasive or lower invasive or moderate invasive. Right? And another point is like that now the working with this multi-dimensional index, unlike like that the poverty, of course, is maybe generally we talk about the income level, but even that is also wrong, because what we usually do is like that the poverty, of course, there are many factors also there, right? So what our aim is like that, based on these many factors, right? Many factors, parameters, how to develop the index, right? And another point is like that these some of the factors are numerical factors. Now, for example, number of seed, that can be of course measurable, right? This is a measurable value. You can find out the numbers, right? But the variables like that, the appearance of the tree, appearance of the plant, which is a qualitative factor, right? If it is highly appearance, people take it, but the lower appearance, so it's a qualitative. Now we have a quantitative factors and the qualitative factors, right? Now, so how do we of course like that use these quantitative factors, right? And the influence, and also like that how do you of course find out the dual of the index, right? Now, most of the things, of course, if you see about that this invasive plant, there are no, the data is not clearly available, right? For example, if you consider about that the number of seed, right? Of course, the number of seed, and then as I mentioned about that, now this papaya, high number of seed, but it's not invasive. Therefore, now determining this invasiveness, we need to actually bring in the expertise ideas also, right? Why this is? Because this is, you can't actually take the data only, right? Now, I don't know whether now you learn about like the subject called subcomputing, right? The subcomputing is like, the idea is like that if you are not of course expecting the exact solution, right? Approximate solution, you can actually talk about this is subcomputing, right? Now, what is the subcomputing? Subcomputing is like we call it, another word is fuzzy logic, right? Fuzzy logic. Now, what is the difference between the passive logic and the traditional logic. Now, traditional logic, wherever you have an in and out, right? In and out mean like 0, 1 and 0, or the present and absent, right? So that is the basically the traditional logic, right? But then when you talk about the go out, right? For example, you are and 1, right? So that's the now when you consider about that what you talk about the fuzzy logic, so the fuzzy logic variables now which of course generate the any value between the 0 and 1. So we call this like that is provide the membership value, right? Now say example, if you take the one parameter, not the third parameter, as a young, right? So how do you actually define the young? When you say like that is based on the age, right? So then the classical logic, you identify the one threshold, say example 30 years, right? You consider the below 30 years as a young, and after 30 years you consider as a old, right? And then there are issues come Like for example, now what about the 25 ages? Yeah, about the 12. So we, according to this definition, young. And even the 29 young, and then the 29 years, 340 days is young. But 30 plus 1 day considered as the old, right? In like that, now this usually the normal logic, classical logic, there are uncertainties. This uncertainty, of course, because of the classical logic, overestimation and underestimation. For example, if I ask over the today's lunch, so and allow you to, of course, answer good or bad, what has happened? So if it is really good, then the people say good, right? But if it is not really good, but you don't want to say bad, then you will say good. It's the overestimate. Then the other thing is like that now, it's not really good, really good, but you don't want to say good, then you are taking the bad, right? You can't estimate. So this is a classical logic, overestimate, underestimate. And wherever is the now the logic, what talked about the fuzzy logic, we can allow, now we can allow 1 to by scale, right? Now you like that they say how was the lunch, good, satisfactory, bad, very bad, right? Actually, this idea is always, now for example, if you mark your papers, so we give the marks 1 to 100, right? Rather than actually telling about that you pass or fail, but we give the 1 to 100. But things like that is also the what we call fuzzy logic. But the fuzzy logic, why this 1 to 5 scale or other kind of things come? Because as a human, we cannot differentiate. The two numbers, very close numbers, concerning without having the measurable thing. Right? But your answers are measurable. That's why we give the 89, 78 numbers, right? But when you look at like that, this appearance of the tree is not measurable, right? So the measurable things is not possible to identify the too many values, right? So that's why we considered about this 1 to 5 scale. But which is actually the beyond that point, what we do is like that we develop the membership function, right? Rather than, of course, giving the value, we identify the membership, right? Now, for example, the young, so you can define the function which is in between 0 and 1. Output is in between at 0 and 1. So the age, right? Age is generally like that, considered as a real number. So you are now mapping the real number to the 0, 1 interval, right? So which is you can consider as a membership function, right? So the membership function, now if you consider the age, so the some particular age, you that the membership function is 1. For example, earlier case, 30 you consider it as the young, for 25 to 30 you consider it as the young, then the people who are in the 25 to 30 get the 1. So then the 24, 25 is getting lower, and then after the 30 getting lower, right? So that you can consider about the young, right? So there are like a well-known membership function. You can see that the trapezoid membership. Variables like that, you have a one height, right? And then variables you can have like a one area. So that area, of course, you consider it as young. Right? Example 25 to 35, we consider the full membership, it's a young, and then the other things are less, right? And also now another classical membership function is a triangular one, right? Previous trapezoid, triangular, and there are what you call the Gaussian membership function. Then also like that the numbers also. Likewise, now for example, if you consider the 1 to 5 scale, which are just giving the numbers, right? So that's the use about the fuzzy logic. Right? Now why this fuzzy logic is okay? You can find out that you can get the expertise ideas, right? Now working with this ecological uncertainty. So our knowledge is of course concerning about the sum of the pattern, identification of the sum of the pattern is less, right? So we can actually meet and discuss with the plant scientists, right? So the monads like that the expertise in this plant, right? So now one important point is like that. Now, for example, I mean, if you are doing the statistics, you do the surveys, right? Surveys, normally the sample size is important. No? Higher the sample size, we believe like that our answers are more accurate, right? But the physiology, we are not actually doing the survey. We try to get the expertise idea. Right? So these expertise ideas, you don't need actually the many people. Like even the 3 expertise is sufficient. Now, one classical example is now if you are suffering with some disease, you actually go to the doctor and you get the doctor said like that you need to do the surgery. And then what has happened? Then we try to get the second opinion. Second opinion means another expert idea. Right? We are not actually going to the 100 doctors and find out whether the surgery is acceptable or not. Right? So the thing is like that. That is the concept. Right? That the expertise ideas more or less like that. If you get the 3, but generally we don't allow you to take the 2 because 2 is I mean the even number. Then we are unable to decide if it is like that any type of like ideas bring out, right? But however, now the 3 is of course always like that. Now even the opposite ideas come, but we could of course sort out it like that. The 2/3 is also there, right? So generally, 3 members is sufficient to get these ideas, right? So what we have done is now here. See like that now what we of course all these parameters we cluster according to the numerical cluster, and also the other one is a qualitative factor. Example, appearance is a qualitative factor. In the quantitative factors, number of seeds, right? And the number of like the time, like a certain of course like a seed we can keep a longer duration, right? But about like that there are plant even now that the seed preserve many years, many number of years. After even the 10-15 years also later, certain seed of course if they get now their preferable climate condition and other things can get the plant, right? Wherever it's like that, the most of these vegetables and the fruit items, you can't preserve the seed, right? It be like that after 2-3 months, now those seeds are not very well. Right? Now, have like now certain parameters called numerical, quantitative, certain parameters qualitative. Right? Then we use certain type of, identify the membership function for the numerical values, right? Membership function for the numerical values, how we identify that of course like basically the getting expertise ideas and then also looking at the literature, right? So you can identify, right? So the prompt actually we develop the membership function, right? Now imagine like that just example, if we have if we have five parameters, then we are having the 5 membership function. Then how do we actually work with? Now there are operators like a physiologic operators like Hampton operator, Einstein operator, so certain kind of like operator. These operators are generally called as generally of course like that to find out the joint distribution, right? Joint impact, right? Now probability also the same, right? For example, one variable you can find the probability distribution. In the 2 variable, you can find the 2 probability distribution, and then you need to find out the joint impact, joint distribution, right? They are also the same. Like, for example, 2 variables, of course, is the Poisson distribution, and then you can find out what is the joint distribution. And obviously, like the 2, each variable, Poisson distribution, and then generally, that feeling, joint distribution is also the Poisson, right? But if one variable is gamma distribution, another variable is the beta distribution, then we need to actually work, right? So here also the same thing, right? But here the functions are different, right? So the coupling of these things, that we need to actually carefully identify the operators, right? So the finding the operators, and then of course to work with the qualitative factors, there are physiologic concept intervals, right? So identifying the interval, it is usually called actually the interval mathematics, right? So the interval mathematics, and then based on this, finally, of course, able to of course develop this index. From the index, we could find out the, we of course use the databases, right? Databases mean the existing plant, right? Identified as the invasive plant. So taking those factors, validate the model. Then also we identify that taking the non-invasive plant also we check whether the model or our index work, right? So that's basically the things what we have done. A lot of things and that is also related. Then the next point is like that now when we of course develop this kind of like an index, right? So to use this index, people need to know about the mathematics. People need to know about even the plant also. And that is not useful, right? The next step is like that we want to actually develop the simulation type of like a model. Like the index should be actually simulated, right? Kind of like a dashboard. The app is actually the AI part, right? The artificial intelligence part. Then so what we do is like that even if you are you don't know the physiology, if you don't know the mathematics, but if you get the plant and if you can identify that the factors, for example, you found the plant and then you calculate about the found out the number of seeds and the number of whether the appearance is good or bad, and then you just include those parameters, right? Those parameters into your AI type of like model, and then finally the output of course come in as a invasiveness. Right? Maybe it's a color bar. Color is like a red color is the highly invasiveness, and the orange color is the moderate level, something. Right? So that is actually that type of like a thing. This the AI type of index is also important. Right? And finally, of course, I didn't actually involve in here that part, right? But that is the main thing. So that the invasiveness that can be now identified even in the layman person, but obviously need to know about the plant, the information of the plant. Right? So taking the information from the plant, just into the here, the output that you are getting at the level of the invasiveness as the color code, right? Actually, so summary, the environmental sustainability. The topic is ecological concept actually determine the invasive plant, right? The invasive plant is generally considered as a biological concept, right? But what we use mathematics, compute, right? Physiologic model, and also the AI type of science. So develop this invasiveness